apparently we got signals coming to JavaScript. Okay, TC39 proposal for signals. Let's see what we got here. In August last year, I mentioned that I wanted to begin pursuing potential standards for signals in TC39. Today, I'm happy to share that a V0 draft of such a proposal is publicly available along with spec-compliant polyfill. So this would be a strawman, right? Is that where they start off at the strawman proposal? Right? Well, what are signals? A signal is a type of data that enables one-way data flow by modeling cells of state and computations derived from other state/computations. The state and computations form an acyclic graph where each node has other nodes that derive state from its value, sinks, and or contribute state to its value sources. A node may be tracked as clean or dirty. All right, I want honesty here. For everybody that did not understand what was just said, can you press 1? Too big brain for me. I just assume they're talking about what's called solid signals. Effectively, when you try to set it, if you have other pieces of code that use it, it automatically gets re-executed. It's kind of like how you're doing it. It's like it's like an observable. The hard part about observables, you also have subjects and then. But what does this all mean? Let's take a look at a simple example. Imagine we have a counter and we want to track, right? So we'd have this one. We have a new counter. Okay. Can we read it with get? Yep, you get the value out. Can we set it? Yes, we set it and we get a 1. Okay, fantastic. Now let's imagine we want to do that with another signal that indicates whether our counter holds an even or odd number. Computed signal is we get a value and we ampersand 1 equals 0. Damn, this man's not even hitting you with a modulo 2 equals 0, going straight in with the ampy 1. Okay. Oh man, you can tell this man's a Chad level programmer right here. Love it. Absolutely love it. Avoiding the divided by operation. Okay. Nice. Let's go. Computations aren't writable, but we can always read their last value. Is even false. Set to 2 is even true. What is ampersand 1? It's pretty straightforward here. Just for those that don't know, let's pretend you had the value hexadecimal 45. Okay, hexadecimal 45 is represented like the following. There we go. Okay, obviously hexadecimal 45 is equivalent to 69. Nice. And with it, if you were to do an ampersand 1, what you're doing is you're doing this value. Ampersand 1 is represented like this. Right? There we go. Fantastic. And if you did an and, it just does, is it 1 and 1? Yes. Is it 1 and 1? No. 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 It produces this, which this value, of course, is equal to 1. And long as we have this, bada bing, bada boom, you got the idea out, okay? It's bitwise operations. Remember, everything on a computer is represented by 1s and 0s. Numbers are 2. Numbers are base 2. Well, 2's complement for the negative numbers, which I can't remember exactly how 2's complement goes, but all I know is it allows for easy addition. Computations aren't writable, but we can always read their last values. Okay, in the above example, is even is a sink of counter, and counter is a source of is even. Okay, fair. Yet we can add another computation that provides the parity of our counter. Parity seems kind of odd that it called it parity. I'm not really sure what that word means. This guy must write language specs. So we have a parity source is even, and is even is a sink of parity. Even if we change the original counter, the state will flow through unidirectionally to parity. Does everyone understand this? Pretty cool, right? It just means that you can create values that react to other values in your code. I've been thinking a lot about this. Do I like this? Do I think that this is a great idea? And I'm going to say something that people might find a little bit offensive, which is that I don't know how much I love signals beyond purely UI coding. I like it, and I'm also worried that it's going to create such an effing tangle. This feels like the world's greatest spider web that has ever been created. I'm curious how debugging works. When you do a get, how does walking through the state work? Deadlocks coming to JS? You can't create a deadlock because they're one way, right? They're acyclic, so you can't. Function pointers are awesome. I feel like it's going to be really difficult. The thing is that at least if you're just directly tied to a UI element, I think we can all kind of agree that it just fundamentally makes sense. I want to set a value that just shows up on screen. We're all on that team. But this, I don't know. I don't want people doing non-UI things with this. If you acquire 2 signals, Let's see. If you acquire 2 signals in a row, can you deadlock? You can't deadlock because it's a cyclic graph. Anyways, I'm just curious what people might do with it. It feels like it like I've never loved higher order components. I've never loved higher order functions generally because people that use higher order functions tend to use them everywhere. And once you start using them everywhere, you start getting into this just like this. Oh my goodness, you just start getting into this thing. You know what I mean? Right? It just starts getting really, really convoluted. And then all of a sudden you're just like hopping into so many function constructions over and over again. And it feels pretty painful. Whereas I do like I've used them to solve many of things and I like it. But at the same time, using somebody else's higher order function set can be such a pain in the ass. Right, starts getting into functional programming. I find the thing about functional programming so hard is that other people's functional programming sucks to read, and mine is awesome to read. Everything we've done so far seems like it could be done through normal function composition, but if implemented the other way without signals, there would be no source sync graph behind the scenes. So why do we want that graph? Recall that I mentioned signals can be clean or dirty. When we change the value of counter, it becomes dirty because we have a graph relationship, and we can mark all the syncs counter potentially dirty as well. Oh, interesting. Think about the potential performance implications here, people. Like if people start using these things, I mean, I'm just trying to figure out why you'd use them for anything other than UI. Maybe nothing, right? Maybe there's nothing here you could actually use it for reasonably. But I'm just so curious about what could be done here, right? Like you have to crawl a graph, crawling a graph ain't free, right? It's pub sub for the front end. It is pub sub for the front end. Anyways, there's an important detail to understand here that the signal algorithm is not a push model. Making changes to the counter does not eagerly push out an update to is even. Yes, it's a pull model. And then via the graph, an update to parity. It is also not a pure pull model. Reading the value of parity doesn't always compute the value of parity or is even. Rather, when counter changes, it pushes only the change in dirty flags through the graph. Any potential recomputation is delayed until the specific signal's value is explicitly pulled. We call this the push-then-pull model. Dirty flags are eagerly updated, pushed, while computations are lazily evaluated, pulled. Sub sandwich, yeah. There are a number of advantages that arise out of combining an acyclic graph data structure with a push-then-pull algorithm. Here are a few. Signals computed is automatically memoized. If the source values haven't changed, then there is no need to recompute. Unneeded values aren't recomputed even if the source changes. If a computation is dirty but nothing reads its values, then no recomputation occurs. False or over updating can be avoided. For example, if we change counter from 2 to 4, yes, it is dirty, but when we pull the value from parity, its computation will not need to be reran because is even, once pulled, will return the same result for 4 as it did for 2. What I mean by that is that it said this. Okay, a false or over updating can be avoided. I understand this principle. It only runs things that are dirty. For example, if we change counter from 2 to 4, yes, it's dirty, which should make is even dirty, which should make is like parity dirty. But when we pull the value of parity, its computation will not need to rerun. I don't see how that's possible. Because is even, once pulled, will return the same result for 4 as it did for 2. Does that mean signals can only be pure? Signals have no chance of being non-pure, so you couldn't make like a counter of how many times something's changed. Interesting. Okay, maybe I do get it. I'm going to be real with you. I don't understand how the fuck this it does that. Well, it does it. It's pretty simple. Here. I can draw how this exactly works. Okay, so we have a counter up top. In here we have something called a dirty flag, and we have last value. It's pretty simple. From here, we have is even, right? Is even, which has these 2 flags again. We have D and L. From here, we have one more, which is parity. When we change counter from 2 to 4, it marks as dirty, dirty, dirty. Then, when we pull with parity, it goes like this. Okay, I'm dirty effectively is my sync dirty. These syncs need to be recalculated because these syncs are used in here. Dirty is like, okay, I need to repull from counter because counter is dirty. Pulls it down, bada bing, bada boom. I'm not really sure how the dirty flag changes in this sense. Maybe the dirty flags aren't stored on here. I probably am storing the dirty flags wrong. It's probably something more like counter is dirty, and this one probably has is even is dirty, right? It probably dirties it this direction, and so once it calls this, then it can set it to a 0. That's probably how it works. So it probably dirties it on a per signal basis, right? It doesn't have a dirty on itself, but on the references to it. That probably makes more sense, yeah. And then when it calls here and it gets an answer back out, and then this value comes out, its last value is the same as its current value, which means did it change? No. So when parity sees that all of its signals though we're marked dirty, changed no values, therefore parity does not actually run. And therefore we return out its last value. Does that make sense? That's how this is how I just initially recognize this thing being implemented. Now, I may be incorrect here, but this is kind of how I'm thinking about it. Does this make sense? I think it does. So I may be incorrect here, but that's how I read this statement. As I read it just like that. So hopefully that makes sense. It's a little bit tricky. By the way, this is a really good exercise for you guys to do, and this is really something you should do more often. Right? Really, real talk, you should do this more often. Is you should read something like this, and you should be able to implement it. Meaning that I just was able to take a sentence we read and kind of came up with the entire chain right here of how it probably should be implemented. We probably need referential dirty flags, and I should be able to go up the chain and down the flame. We probably need a last value, and we need to compare current value versus last value. Like, we need to go through all of this, right? But I'm not a masochist. Well, you can think it. You don't have to implement it. Like, can you think through it to the point where you could implement something? I think a lot of people don't go through that and think about how things are implemented. All right, we can be notified when signals become dirty and choose how to react. These characteristics turn out to be very important when efficiently updating user interfaces. To see how, we can introduce a fictional effect function that will invoke some action when one of its sources become dirty. For example, we could update a text node in the DOM with parity. Okay, we have an effect that uses this. Man, comments on the bottom is crazy. This is crazy. Effects callback is run, and the node's text is updated with odd. The effect watches the callback source, parity, for dirty changes. Okay. Dude, crazy to do this. All right. Counter set to. Counter becomes dirty at sinks, resulting in the effect being marked as potentially dirty. So a poll is scheduled. The scheduler begins to reevaluate the effect callback. This is very interesting how they're going to map the scheduler. Do the schedulers run like promise timing? Does it get thrown on the kind of the micro queue task, or how does it run? Parity begins to evaluate by polling is even polls counter, resulting in a change to value for is even. Because is even has changed, parity must be recomputed. Because parity has changed, the effect runs and the text is updated to even. All right. So this is where, let's see if I'm correct on my thought process here. The counter is dirties its sync, resulting in the effect being reran, marked as potentially dirty. So a poll is scheduled. The scheduler begins to reevaluate the effect callback by polling parity. Parity begins to evaluate by polling is even. Is even polls counter, resulting in the same value for is even as before, resulting in a new value from counter, but the resulting output of is even is the same as last value. Last is even is marked clean. Because is even is clean, parity is marked clean. Parity is clean, the effect doesn't run, and the text is unaffected. Okay, so you're hoping that that level of computation is cheaper than updating the text content of the node itself. So that would be the goal of signals, which, I mean, very well could be, right? Hopefully this brings some clarity to what signals is and an understanding of the significance of the combination of an acyclic source sync graph with its push then pull algorithm. Late in 2013, I partnered with Daniel Ehrenberg, Ben Lesh, and Dominic Ganaway to try to round up as many signal library authors and maintainers of front-end frameworks as we could. Anyone who expressed an interest was invited to help us begin to explore the feasibility of signals as a standard. We started with a survey of questions and one-to-one interviews, looking for common themes, ideas and use cases, semantics, etc. We didn't know whether there was an even common model to be found. To our delight, we discovered there are quite a bit of agreements from this part. Over the last 6 to 7 months, detail after detail is poured over, attempting to move from general agreement to specifics of data structures, algorithms, and initial API. You may recognize the number of libraries and frameworks that have provided design input at various times through the process so far: Angular, Bubble, Ember, Fast, MobX, Preact, Quick, RxJS, Solid, Starbeam, Svelte, Vue, Wiz, and more. If you store the path, you could exit early and save if the path is long. Oh, really? I don't even know what you're talking about. It's quite the list. And I can honestly say, looking back at my own work in the web standards over the last 10 years, this is one of the most amazing collaborations I've had the honor to be a part of. It's truly a special group of people with exactly the type of collective experience that we need to continue to move the web forward. Important, if I've missed your library or framework, there's still plenty of opportunity to get involved. Nothing is set in stone. We're still at the beginning of this process. Scroll down to the section titled, How Can I Get Involved? What is the signals proposal? Okay, this is where it just gets into the specifics of this all. This is very, very interesting. I like signals in theory. In practice, I'm curious, how does signal scale? Like, this is a very interesting observation, which is you open up the signals tab in the dev tools, and there's effectively 1 million individual signals. My favorite thing about tooling like this is that there are approximately a dozen teams in the entire world who are building apps with sufficient complexity to make the addition of signals anything other than tech debt. I think the goal is probably a little bit different than that. I think the goal here is that signals are meant to be used as a way to design UIs. Now, whether or not it's the superior way to design UIs is up to people, right? And I'm not saying they're bad. I think Solid uses them, and Solid, I think, is a step better. I mean, I like the idea of Solid. I haven't built enough big things with Solid to have any sort of really concrete opinion about it, but there's a lot of things I like about it. Client state management. The problem I generally have with client state management is that the client is one of the worst places to keep state. There's a few places in which clients are great to have state on, but a lot of state just kind of sucks for the web. I'm you know me, I'm more of a server deserves the state than the client does. I will probably always be that. Again, that's why right now we're building our real-time NeoVim renderer, because I just find it nicer. Signal/RxJS are very nice. You just need to be careful from back pressure. That's all I have to say to that. Would you agree that there does need to be a standard client-side state management, or should that not be standardized at all? Let me tell you a little secret about standardizations. There are 14 competing standards. 14, ridiculous. We need to develop one universal standard that covers everyone use cases. Yeah. Situation. There are now 15 competing standards. Obligatory XKCD. This is what you just suggested. And it's not that I don't think you're doing it out of a good place. It's just that that's what will happen. And I'm going to check the alt text too. Fortunately, the changing one has been solved now that we've all standardized on mini USB, or is it micro USB? It's pretty good. But I mean, that's the whole problem with these standards, right? Anytime you have a standard, you're gonna have people that don't like the standard. But why signals? Or is it USB-C? Or is it gonna be micro USB-C? We read this just recently about how someone created their own database and greatly improved their cloud performance, just demolished their spending in the cloud, despite the fact that they definitely spent more in engineering hours than in the cloud, but nonetheless, they're attempting to scale for the future. The problem with any generalization is that generalization works in the 80, 85%, 90% of the time. The other 10%, it doesn't work well with. And even though it's great, and I'm happy we have these generalized solutions, sometimes you have to make non-generalized solutions for yourself. And this is why client-side state is so hard. Whatever client-side state you need is likely very unique for you and your application. It's likely completely different how you want to do it, how your engineers think about it, depending on the type of technology you choose to use your front end, whether you're going with strictly web components, Solid, React, Vue, or some other thing somewhere far in between, right? It's just that everything has its own way of doing stuff, and it becomes excessively hard. And I've seen so many bad implementations. It's good that there's diversity. Unsure. I don't know if it's good or if it's bad. It's hard to really state that because I find that the things are very emotionally painful. A UE5 game needs different state than a Wikipedia. Yes, I mean, again, I'd be stupid to try to compare state management in video games to the web. Signal assumes you never lose state. Signal is the state holder, right? Signals is the state holder itself. The PEMDERS people have a good approach. They have Zustand, which is Redux-like, Velatio, which is a proxy-based, and Jotai, which is atomics-based. Pick and choose, but you know it's the same solid crew maintaining it. Yeah, I mean, it's an interesting way. I'm mostly in the HTMX camp and minimize. As far as I can tell, whenever I have to do anything with UIs, I try to go with locality of behavior as much as I can. The amount of disasters I've seen with React and keeping state in React and Redux is a nightmare. But I've also seen big ones, right? I've seen some really big ones, and they're just such a piece. You know what? I love Jay Phelps. Okay, this is not an attack against Jay Phelps. I think Jay Phelps is a champion, but most people don't have back pressure issues. Okay, this is just not the thing that we're going to talk about or even need to think about. Okay, Redux just tried to bring Elm state management to JS. Yeah, and and the thing is good ideas in one language doesn't mean it's a good idea in every language. Anyways, background, motivation, design goals. Okay, so it has all the stuff we're going to have to talk about. Signal's proposal does not include an effect API, since such APIs are often deeply integrated with rendering and batch strategies that are highly framework library dependent. However, the proposal does seek to define a set of primitives and utilities that library authors can use to implement their own effects. Hell yeah, we're about to get ourselves 6 implementations of effects, people. Here it comes. On that note, the proposal is designed in such a way to recognize that there are 2 broad categories of Signal users: application developers and library framework infrastructure developers. APIs that are intended to be used by application developers are exposed directly from the Signal namespace that includes signal.state and signal.computed. APIs which should rarely, if ever, be used in application code and more likely involved in subtle handling, typically at the infrastructure layer, are exposed through Signal Subtle. These include Signal Subtle Watcher and Untracked in the introspection APIs. Yeah, I'm still worried about some of this overall. Like, again, I always worry, because the thing is that you hear this stuff and you can everyone has an immediate use case in their head of how they could use this. But you just got to remember that in everybody's head, how they're going to use it and what they're going to use it for is going to be slightly different. And then you're going to join a company and you have to play this game of how did my data get there? Right? And I find that these disconnects can be very frustrating sometimes. We add an incredible amount of difficulty just to update a value. And sometimes there's some justification for why it exists, but I'm not always convinced. Yes, it is. There's going to be a terrible amount of weird patterns, right? There's going to be a terrible. We have decided that this wasn't hard enough to debug. So we're going to make you think about a signal priority order and data lifetimes. Absolutely. All right. Let's see. We interrupt this blog. Okay. Oh, I do like web components. I wish I loved web components more. I want them to be awesome, but I feel like they're such a pain in the butt sometimes. As an app developer, how do I use signals? I think this is probably not really very interesting right now, but you get this. It's just going to be doing some sort of nice little, do something beautiful, do a little counter. Oh, look at this. Look at this beautiful counter we got going on here. Look at that beautiful counter. We got even private variables. Look at that private variable. Look at that private variable, signal accessor value. Wow, that's quite the modifier. Class, yuck. Okay, well, I see enough for it right now. I think we all get the idea of signals. I'm curious. I'm curious what the next 5 years are going to look like for you JavaScript people. Good luck. I hope that you guys enjoy all of the new features that are going into JavaScript. I'm just actually, one thing that's really funny is that JavaScript, in some sense, is like racing to become like C++. You know what I mean? It's like it's racing to see how many features can it cram into a language, and it's going to give you every possible way to do something. Ring zero, JS is the future. Enjoy the nightmares. Yeah, don't get me wrong, JS can be, for a UI developing language, it is very useful. Loosey-goosiness is truly just needed in a lot of UI development. Like, that's why I enjoy using Lua to make the Vim stuff. I enjoy the loose goose nature. I'm not against it. It's just that there's a lot of difficulty to it as well. It's a huge pain in the ass sometimes. The name. Good luck. C++ JS. Whatever you call yourself these days. Again.